today I was going to talk a little bit about how the architecture of the program is, how you run it, and show a little bit about some points in the code which I think are interesting. We do not have, the time to do this in depth for all the system. That is not possible. So I've picked some topics, and then from there maybe we can generate some discussion, or but we won't be able to go through every aspect of the system today. But I was going to I was going to talk about a little bit the config, how we kind of set up the system, and then the API service, which serves REST endpoints, how that works, how you can try it out if you have Chrome, and then inject some headers. I was going to show how we implement a new endpoint. It's a completely bogus endpoint, but just for the sake of how, if we want to add some functionality in the system, how would you do that? I'm going to look a little bit at the endpoints which are connected to the database, because that poses some interesting issues. How do you connect to DB? How do you know that you're authorized to look at what you want, and how do you test it without spinning up loads of stuff? I'm going to talk about the security model that we have, how we do authentication and authorization, and how we pass that on to the database. Let me see, can I click? Will it give me the next slide? Yeah. Okay. So the configuration of the system is read from file and environment variables. Typically, I think the suggestion is to always use environment variables, but I feel that it's nice to have some kind of skeleton checked in that doesn't have any dangerous or any sensitive information in it, and then you can override some of these configs by environment. That is the path we have chosen. We use the Viper config package. Are you familiar with how familiar are you with Golang?
Yeah, I'm as I said before, I'm Golang developer, and I'm familiar with Golang.
Yeah. Okay, super. That's great. And Helge, you're moving into this, or just?
Yeah. I have none, but it's readable at least.
Yeah.
So
Yes. Yeah. Okay, so Viper is the package that we're using. It's a little bit fickle. If you try to override a config that was not in the YAML file, it doesn't work as you want. So it's just good to pay attention to that. And then from the config, we have several groups, and the idea is to produce a struct inside a parsed struct with the data, and then each group can provide, like, if you want a DB database client, you can produce a new database client from the config of this substructures. That is the pattern. To make it a little bit you start up the program, moved out all the endpoints, it will walk over the path and print out all the endpoints that you have, and that the service serves. You have the server, Alexander?
Yes,
Yep.
yes. Now everything is working fine. I had an issue and I created one on GitHub, but it has been fixed by restarting the project locally.
Okay.
I deleted all containers. Yeah, so now everything is working fine.
Yeah, that's really nice to hear. So, are you familiar with the HTTP and the muxing in Golang?
Yes.
Yeah, super. Okay, then this will not be so difficult. But
Absolutely.
the idea is that we have a service and you get some requests, and then we have a muxer that looks at the request. What do we want to? What path are we looking at? And then our system. So these are kind of the groups of endpoints that we have. And the kind of the nice thing with the Gorilla Muxer is that you can group you can put a group of endpoints into a group, and then you can put some middleware on that to make sure, for example, if I'm looking for something that I know will produce JSON, then I can set the content type for these requests, or for the headers that are sent back. So you can do lots of nifty little things with these middleware functions. And then maybe if I share my screen instead, I think that would be a bit crazy, but will it work? Okay, nice. Okay. Okay, so you can see that I've just have this the slide that what if we want to create a new endpoint, then and then we would go to the REST package and the REST file, and you can see that it has this register routes function, and this registers all the available routes and the sub routes and adds lots of different things. So if I want to make a new route, I would add it maybe at the end here. Register history routes. Subrouter dot. Think like this. So I added a little file with the history route, and inside of it there's the register function. It just checks to see that it will send back JSON, and it adds a handle func to the history, and then it uses the history handle to serve requests, get requests at this point. This history handler, it will require the context that you get with the request, or not with the with the request, and it will just write this as a response and say everything is okay. So it can't fail. if it doesn't get the history from the context, it will return an empty set of strings. And then this is not the way to obviously not the way to do it, but this is how I did it for the sake of this presentation. So I added a little middleware func that gives you a history, that injects history into the context. What it does is it takes this little history array, it locks it, and it waits to unlock until you exit the scope. And it will append to the history the URL of the request. And then if history has gone too long, this is a silly way of implementing a sized queue, but that doesn't really matter. Then it will just slice the history so that it's at most 10 items long, and it will create a context that has the history in it, and it will continue in its serving with the context that contains the history. So what we need to do now is to make sure that because if we do this now, I added the history route to the serving. So if we do this, okay, and then I have the program running here in the background, that's server. So you see, it will serve history at API v1 history. Okay. API v1 history. Okay, I actually had added the middleware, so you can see that every time I user info, then if I go back to history, I will also have user info here. Yeah, it's a silly example that shows how we add a new endpoint, how we use the middleware to inject something into the context, which is a nice way in this service setting to make sure that you have some data which is local to a request that you get out, that propagates all the way down. It's a typical pattern, but you obviously wouldn't make the history itself a package variable like I did. Then let's see. There are some any questions I mean about this? It seems that you're aware of these concepts already, Alexander.
Yeah, everything is clear.
Yeah, great. Okay, then you will have lots of fun improving the system and maintaining it. That's great. And then if we in the next step, we need to not only read something which may be contained in the context or maybe static, but we want to access some other services like the MongoDB or the Kubernetes system. To do that, it's important. I mean, it's important obviously, but it's a very common Go pattern that you abstract the access with an interface, because that also makes it possible to run the tests without starting up a Mongo database and having to wait for that. So the interfaces for the database access, it's called the component client, because at some point all the objects were called components. historical reasons. It's in storage package in storage.go. Can just take a quick look. Storage there, the component client, and it serves all the documents we have. We have the components which we build the workflows from. It has the workflows and the different types of endpoints, and I won't go into details about the different ways today. It also has some jobs and some events and some extra. So basically, if we look at something, let's look at the components. If you want to list components, then in the register component routes, we have a handler for /component/ and the get method. And it's because it's a little bit the same for workflows and jobs. They share some common code, but it's a component list handler, and then it goes into the component list handler. This one, the one that handles a list request, obviously has a writer and a request, and it tries to parse some pagination from the queries, if there is any. And then it continues to this database client, and it says, because we are going for the component, then list components metadata. Some of the documents can grow big. They can have lots of things inside them. So when we list many, we typically only list the metadata, which is enough to later retrieve the full document, but it's a lot faster. We do that together with some filtering and sorting. Let's see, we then go to the Mongo that list components. Okay, so this is the Mongo client database that implements the components list components metadata. So we build a pipeline, and then add the filters and the sorting, and then do some projection, because we only want documents with the metadata, not the full metadata. And then we append some splitting, because we don't want all the documents. And finally, we run this Mongo aggregation on this. Are you also familiar with the Go Mongo interface, Alexander?
I did not have a chance to work.
No. It's not so. It's nice. It's nice Go interface, and it's not so difficult. Well documented. Yeah. So we run this aggregation, and we get back some kind of we get back an iterator. We iterate over all the documents and fill out this list, and then we also add some page info, which is the offset and how many items we read, and then all of this is returned. So it's quite straightforward. There are some implications with regards to security that I think I have on a slightly later slide, but it's typically you wash the request in the REST handler, and then you send it to the Mongo client, and that one will try as well as it can to give you a result and send it back. The same is with the Kubernetes access, or we have a secret client. Maybe we can secret. And the secret client, it can list the available keys. We can add a key and we can delete the key. That is the capabilities that we expose, and then we use the Kubernetes infrastructure to achieve this. But in our handler, secret list handler, we just call the client to list the available keys, and then if that works, it writes it back. So maybe we could try it. Secrets. V1 secrets. Didn't look so promising. Secrets. Oh yeah, I need a workspace. Sandbox project A. Is that a project B? Yeah. Okay. No. User info. No. There. Info. Roles sandbox developer. Oh, okay, so maybe just sandbox secrets. Sandbox. No. Okay. I don't know the name of the. Okay. Of course I do. It's in the workspaces. Okay. I don't have any workspaces in this setting, so I can't have any secrets because I'm not entitled to any workspaces. That's why I couldn't get any. But that is pretty standard. I wanted to talk a little bit about the security model, and we have only one grouping, and that is what we call the workspaces. You have looked at the deployed version at Flowify.Aurora, Alexander.
On Aurora, no, I did not.
Okay, yeah. Because I don't have access anymore, but maybe you can post the link and make sure that he can do that, Matt.
Yep, I can do that.
Yeah. Because there you will have workspaces set up, and if Matt is nice, you will also have some access to this, and that is, I think that's the best way to look how it's working in a deployed setting. Anyways, the workspaces, they're like, you can think of it as projects, and some people will have access to a specific project, and some other people may have access to other projects, and inside a project you have a lot of freedom right now. That is something that we maybe will work on in the future. And you are granted access to a workspace by the roles or extra claims or whatever it's called in Azure AD. And then if you have the role called, for example, Sandbox, then this user will also have access to the workspace called Sandbox. So that is how we have matched the Azure roles with the workspaces. And I should mention here that the workspaces, they kind of correspond to what you would call namespaces in Kubernetes, but it's not implemented the same way. But it kind of gives you a limited view inside into the system. So given that you have some roles, when a request, maybe I should go to the next slide here. Yeah. When a request comes in to the service, we can do the access control quite early. We don't have to send things further. We can stop them already if we see that they don't have access to the system, which is nice. And we use the OpenID token, and I think that's set up in the proxy, or how is it again, Matt?
Yeah, we have an OAuth 2 proxy sidecar. So all of the requests go to that sidecar, and then it gets sent across to the Flowify server if it is allowed.
Exactly. So actually, there's already some kind of the access is somewhat controlled. But when a request comes to us, we will check that they have the tokens that we want. We will validate the tokens, and we will verify their signature with the published keys that we get from some Equinor URL that is configurable. Right. And then we have some authorization for individual objects, role-based access control. And that is basically just using the roles to identify which workspaces you have access to. And then we can see that to grant or deny access to paths, for example, it's a little bit easier, because in this setting where we're looking for the secrets, like I did, but didn't have any, I know that I will always be looking at a path variable called workspace. And I can authorize the request based on that path variable. I don't need to go into the to go into the handler and go into the Kubernetes system to see something in the secret, because I know already that the secret comes from a workspace, and that can be authorized higher up in chain. But on the other hand, if I want to list the workflows that I have in the database, there's no way the handler can know what database documents it can show. It has to wait, it has to send a request to the Mongo client. The Mongo client has to do some magic to send back only the documents that are that you are authorized to see, because the workflows are listed in a flat or in the same table, irregardless of what workspace they are in. So we must do that in a secure manner. And if you want to get the single workflow, the ID doesn't tell you which workspace it is in. So you need to query the database for the document, and you need to check the workspace field of the document to see if you're authorized to read it or not, and then return an unauthorized if you're not. And for the list request, you need to make a filter and return only those variables that you are authorized to see. And it's important when you make this database filter that, because you can also append some query parameters to the call, you can write some filtering. It's important that when you create this filter, nothing that the user writes has any possibility of bypassing the fact that the database should not return some data which it doesn't have, that the user doesn't have authorized access to. And the way we do it is that we make several stages, and the first stage is just a filter stage that removes all the documents that you're not authorized to. And at the second stage, the user filters come into play, so that the user filters never see any documents that you are not authorized to. It's a detail, but it's important. When it comes to authentication, as Matt said, we use this OAuth2 OpenID token, and the interface is in auth, the auth package, and not authorization, or authentication client. An authentication client just have to do one thing. It takes a request in, and it returns a user, which is then authenticated, and a nil if it passed, or otherwise no user and an error. So the implementation, which is like the only one we're using right now, is the one in the Azure OpenID token. So we have made a struct which contains some of the standard or some of the non-standard claims. And then we use the JWT register claims, which is the ISS, the sub, the odd, and the exp, the expiry. Yeah. And as I wrote in the slide, we need to parse it. There's some nice code for that. We need to verify. It's also done automatically, but we need to retrieve the keys from Equinor's key rollover service, and we need to validate that this, make sure that the values match the expected constraints. So can just quickly look at the validation, which I think is the only mostly interesting thing. So if you want to check that this Azure token was okay, we'll verify the expires at, and we need to require it to fail if it's not, because by default it's optional. It wouldn't give us an error if it was not set, so we require it. Let's see. We check that that the token has not expired. We check that it has been issued in the past. We check that it's not used before it should. And we check that the audience is the intended. And we also check that the issuer is the one that we have registered. So those are set as some config when we start up, when we deploy the system. I think the audience is some kind of key we get from Azure, and also the issuer as well. Is that right? Some special keys from Azure AD, Matt? Yeah.
Yes, I think that sounds about correct.
Yeah. It just means that we cannot, the user cannot get some Equinor token from some other project and say I want to use that token and get access to Flowify. It needs to be explicitly Flowify, and it needs to be explicitly from Equinor. I think that's the issue and the audience.
Yeah.
So where do we? I had some. Where do we inject this checking? And we do that in the REST. And whenever you have questions, you just jump in. So here where we register all the routes, we also use something called new authentication middleware. And that one will call the security client, the authentication client, and say, on this request, authenticate it, or try to authenticate this request. And if it passes, you will get a user. If it doesn't pass, we'll get an error, and then you return. But if it passes, we serve the subsequent request with a context that contains the user. So it's with context with user.
Yeah, that's clear.
Yeah. Okay. Thanks. So, right, that. Right, and then let's say we wanted to not have such a difficult, or not we wanted a simpler authentication. To be able to access the API now, I have used the Chrome add-on called mod header. Are you familiar, Alexander?
This is a package, yeah.
Yeah. So I can inject the authorization token.
I used.
Anyways, that's one way, because now I have JWT encoded this thing here.
Mm-hmm.
Let's just do it so we can see here. JWT.io. Okay, so the token I injected into my context, it has the audience Flowify IO, the issuer sandbox, and this one says it's issued at this fall, not for this fall, and it expires long time in the future, 2052. That's not a token you will get from any real system because it's too long-lived. It's just for testing here. It says an email, name, and then it gives me some roles. And you see here it says we have an invalid signature. I happen to know the secret here, so we can Flowify.io. And this is also, and now it ends with U4A, and I think that's what we had in the U4A. So it validates if you sign it with the 256 SHA with this secret. And obviously you will get much better keys from the key algorithm, but I can't access them without Flowify or without Equinor account. So if we wanted to do some other kind of authentication, we saw that it's just a middleware that injects a user into the context. So one way could be to kind of build a mock user. Let's see. they call it, mock authenticator. This one actually already is inside the auth package, but I moved it out here so it should be easier to see. It's just a struct with a user in it, and when it is asked to do authentication, it will return the user and no error. So this one will never fail. This one could be used in testing, for example. And actually, if we see in the config, the auth config, new auth client from config, it will switch on the handler, and there's the Azure OAuth 2 Open ID, or there is a case called disabled auth that will use such a mock user. So you can start, it's possible to start a service and disable authentication. But I think that this way of injecting context or values into the context is a very powerful tool, and together with some abstraction and clients, it can be used to enable and disable quite a lot of different parts in the code. I think that was actually a little bit faster than, or a lot faster than I was expecting. So I don't have any more slides for you. And then I think I will I would rather open up for questions, and maybe we can, if you like, we can have a short break, get a coffee, and then have a little question session. How does that sound?
Thank you for this presentation. It's clear, and it's probably would be more easier for me because I have an experience with Gorilla Max, and of course I worked with GVT and with Rbug systems. So I don't have much questions, many questions. I have a general one. I was wondering, as I know, a lot of stuff on Equinor works on a Python language. Why Golang was chosen?
I think the decision was springing out of the use of Golang in Kubernetes and Argo. As I briefly mentioned yesterday, the project started using Argo only, but we quickly found out that was not it was not easy to provide something that fit our users. And then, but by then we had quite a good understanding of how Argo did things. And then we continued on that path. I personally prefer statically typed languages for larger systems. Right now, I'm working on a system in Python, which is similar, but not similar. But I mean, it shows the same traits, and I think it's much worse. It quickly becomes slow. You lose the typing and you lose the static checking. And then when you do it in Python, you have to add all this typing and workarounds to make it look more like a statically typed language. But I mean, I understand that you ask, because Python is obviously more well known, especially at Equinor.
Yeah. But yeah, it's Makes sense.